Going to be speaking today, and he is recording our meeting. I don't think we have as many people today. It's pretty heavy rain and people busy with midterms and whatnot. I don't really have any other general comments. Do you, Evan?
Currently, no.
Oh, I guess I could say just by way of introduction for Odin, and also if you're trying to sign in for extra credit, there's a sheet up there for if you're in my reverse engineering course. Otherwise, you can ignore that. Odin recently did just attend the Suricata conference in Boston, so he has a lot of fresh, up-to-date knowledge to share with us.
All right, yeah. Well, thank you, Dr. Brizendine. So I'm going to...
I think you're muted, or hold on, we can't hear you.
Oh.
Echo.
Okay.
All right, we can hear you now.
Okay. All right. Thank you, Dr. Brizendine. So I'm going to share my screen and get this started here. All right, how's that? Can everybody see that okay?
Looks good.
All right, so today the main focus is going to learn all about Suricata. So Suricata is an intrusion detection system. So I'll be explaining a little bit more what that means, but basically this is going to be like a two-part series. So the first meeting today, we're going to be discussing, basically I'll give you a little bit of an intro about like what Suricata is, and we will also be learning, our main focus will be, we will be learning how to write Suricata rules. And then hopefully at the end, you'll be able to write your own, like we'll have an activity at the end and you'll have a chance to practice writing some Suricata rules. So yeah.
Should people power on their VMs or their VApps?
I would say so. I mean, for this one, we don't we're just going to be working with PCAPs. So a VApp isn't completely necessary. I mean, if you don't have Wireshark installed on your local machine, then you're probably we do have Wireshark on the VApp for you. So if you want, you can use the VApp for this. So yeah, you're going to want to, if you're going to use it, then you should probably power it on now, and then we will be later on I'll be doing a demo with Wireshark. So just a little bit. So if you're not already on the Malware Club mailing list, so if you're not on the mailing list, you didn't, like if you didn't receive an email tonight, like earlier today, and then that probably means you're not on the mailing list. So if you're not, you're going to want to join, going to join.malware.club, and that's going to allow a VApp to be pushed out to you and for you to receive communications related to the club, basically. And also, so this presentation is on the Malware Club Drive. So if you go here to drive.malware.club, and then you can access, there should be a folder there called today's date and then Suricata. And then if you click on PowerPoint, then you can download, or you can like view a local copy of this presentation. So then you can follow along if that's easier for you. So just a little bit, I briefly went over this, but just in more detail, what will be covered tonight. So as mentioned, the focus of tonight's meeting will be on how to write Suricata rules. So I'll be discussing the syntax of Suricata rules, like the different components that are necessary to write a rule. And then also I will provide some tips on how to write a good Suricata rule. We will then spend a little time using Wireshark, basically to analyze network activity. And then from there, like you'll need to analyze network activity in order to write the Suricata rule, because Suricata works by inspecting network traffic, and I'll be discussing this in more detail. But so we will also look at examples of good Suricata rules and what makes a good Suricata rule, and then you should have time at the end. We'll have an activity to write, and you'll be able to write your own rule, and then. So as far as configuring and running Suricata, we won't have time to do that tonight because learning how to write Suricata rules on its own is a pretty big topic. So we won't get to actually configuring and running Suricata, but probably in our next meeting, we will spend half of the class just learning about the different configuration options in Suricata. And you also have the chance to run the rules in Suricata that you'll be creating tonight. So let's go to the next slide. So first of all, before we get into how to write Suricata rules, we need to know what Suricata is. So I'll just give you a little bit of context into that. So Suricata is an intrusion detection and prevention system, and it's developed by OISF. So an intrusion and detection and prevention system is one layer of defense that can be used against malware. So it will sit on your network, and then it will listen to the network traffic. And if this matches a rule set for known bad traffic, so it will inspect each packet on your network, and if the packet matches a rule, if it matches a pattern for known malicious traffic, then what an IDS will do, so an IDS is an intrusion detection system. So if it detects a malicious packet, then it will generate an alert. But an intrusion prevention system will actually drop the packet, so it won't forward the communications. So there are a few different IDS and IPS solutions, but Suricata stands out in a few different ways. For one, it is free, open source, and also Suricata allows you to inspect application layer traffic as well. And not all IDS or IPS solutions allow you to inspect application layer traffic. A lot of them just focus on network and transport layer traffic. So there are some similarities and some differences between an intrusion detection system and then like an antivirus, a signature-based antivirus software. So it's similar in that it will look for a malicious pattern, basically a malicious signature, but it's different in several ways. So for one, an IDS is on the network level, and then an antivirus solution is on the host level. So, and then also an IDS will analyze network traffic, whereas as an antivirus will usually analyze the files on the host system. So those just a few differences there. So let's go into a little bit more about how Suricata works. So Suricata, as mentioned before, it will listen on your network interface, and it will analyze each packet one at a time. And then if that packet matches against a rule set for known malicious activity, then Suricata will either alert you or drop the packet, depending on whether it's in IDS or IPS mode. So Suricata can also run in what's known as offline mode. So basically what this means is that you can feed Suricata a packet, and then it will match this packet against a rule set. So it's a packet that you've previously downloaded and not like live network traffic. So you download the packet, you feed it to Suricata in offline mode, and then Suricata will match that packet against any of the rule sets that it has configured. And if it matches on the rule set, it'll either alert or drop it. So that's something we'll look into in the next meeting, is using Suricata's offline mode to detect malicious traffic. So just a little bit on where you can get Suricata rules. So for Suricata to detect malicious traffic, it needs rule sets to do so. So there are several sources that you can obtain rule sets from. So what a rule set is a list of rules that are maintained by the community. So one common rule set is known as the emerging threats rule set. This is a very common rule set, and it's free, so it's not a paid rule set. Some rule sets are free and other rule sets are paid. So emerging threats is good because it's kept up to date, and it contains a large number of rules that make it easy to get started with Suricata. But if you want a custom configuration, there are other rule sets available. So Suricata also has a built-in tool known as Suricata Update, which contains various built-in rule sets that you can enable. And also it allows you to add rule sets from different sources. But the main thing we'll be looking at is actually writing our own rules, just to become more familiar with how Suricata works as far as detecting malicious network traffic. And there are several reasons why writing your own rules can be beneficial. If, for example, if you're analyzing a new strain of malware and you discover it, you can create a new rule and then you can share that with the community. Also, if you're like doing incident response work and say there's a malicious, you find a malicious file on one computer, you can create a Suricata rule and then it could search for if this malware is present anywhere else in the network. So we're going to get into how the format of Suricata rules. And so the first thing that you want to be familiar with is the action. So that's the first part of the rule. So the action is what Suricata will do if that rule matches. So will it alert us or will it drop the packet? And then the next thing is so the header. So the header, the header like defines where the traffic is going, basically. So it includes the destination protocol, the destination, well, the destination protocol, the source and destination IP addresses, and also the direction of traffic, which direction the traffic is headed. And then the last part of a Suricata rule would be the options. And this is the options include various metadata about the rule, such as the ID of the rule set, the message of the rule set. So like when an alert is generated, this is the message that will be shown when that alert is generated. And then also the options contains like the content, the actual content that it's matching against. So the content would be the like patterns in network traffic that the rule is looking for. And if it matches that pattern, then an alert will be generated or the packet will be dropped depending on whether it's set to alert or drop. So the first thing, as discussed, is the action. So I've discussed this before. So there are actually quite a few more different actions that Suricata has, but the most important ones that we'll be looking at are alert and drop. So then the header. So as discussed, so the first thing that's in the header that you want to specify is the protocol that you're using. So I mentioned this before, but Suricata can support transport layer protocols such as TCP and UDP, but it can also detect application layer protocols such as HTTP, FTP, or SMTP. For the source and destination IP addresses, you can either specify a hard-coded IP address, or you can, Suricata has built-in variables, so it has the built-in home net and external net variables that you can set in the configuration. So we'll be actually looking at that in the next meeting, but basically what these do is you can specify your home network and the external network, and then you just use this variable, and then you don't have to hard code. You don't have to hard code an IP address in, which is better if you don't hard code an IP address in for the external, for like the destination IP address, because we want rules to be as we want rules to be broad and able to. So for example, if the command and control server changes, we want the rule to still be able to detect other command and control servers that have the same payload. So by setting a variable for not, so if you don't specify an actual IP address, then it can, if the IP address changes, it can still potentially detect the payload that is being run. So then the last thing here is the direction. So the direction specifies, which way that the traffic is headed. So if the arrow is, pointed to the right, then it's going from the left to the right. So for example, here it's going from the home network to the external network. But if the arrow was pointing the other way, so if the arrow was pointed to the left, then the traffic would be headed from the external network back to the home network. And then you could also specify both ways. So that would mean either direction it would match on. So the last part is the options. So the options, as discussed before, defines what content that the rule set matches on, as well as the metadata of the rule. So a few things to note about syntax for the options. And I think if I go back to the first slide, this just will show you, this is just a better visual representation. So for the options, you need to have like a parenthesis. It needs to be enclosed. The options need to be enclosed by a set of parentheses, as you can see here. And also after each option, you need a semicolon. So for example, here's the message option, and then a semicolon, and then flow, and then there's a semicolon. So after each option, you need a semicolon there. But so we will cover, there are a lot of options. We won't cover all of them, but we will cover some basic options that are necessary to know for writing, for starting to write Suricata rules. And if you want a more detailed overview of the different options, Suricata's documentation contains the full list of options there. So the first option that I'm going to look at is the message option. So the message option is an example of metadata. So the message provides a description of the rule. So when an alert is generated, the message will be shown. And then, so the purpose of the message is to explain why the alert is generated. So some good examples of messages. So they should be descriptive enough so you could tell when an alert is generated, what exactly, how that alert was generated. So so some examples would be of like good messages to have would be like Cobalt Strike C2 traffic, or like crypto locker ransomware payload. So that clearly tells you like how the alert was generated. So yeah, as I said here, so it should be, it should include a clear and concise description explaining why the alert was generated. So the second option that I want to look at is the flow. So the flow is another way you can match on a particular direction of traffic. So flow can either be, so you can do to client, so that will alert on traffic that is headed from the server to the client, and then to server will be from the client to the server. And then you can also write it this way. So you can have also write it as from client. So then it would be just the packet would be originating from the server, from the client and headed to the server, or to the client and then from the server. So, and then but also there's another option you can specify, which is established, and this will only generate an alert if a successful connection was made between the client and the server. So then just here's an example of, so you can use these So you can use like these four together with established as shown below. So then another option is, well, the content option is probably one of the most important options because it will actually specify the pattern that you're looking for in the network traffic that is associated with malicious activity. So this is the actual pattern that the rule is being matched on. So you can use, so content, you can specify this using either, you could just use regular ASCII, and you can also use hexadecimal characters. So for using hexadecimal characters, they need to be separated by these two pipes right here. So that would be how you do that. And then, so as you can, so here's some examples here of how you'd write. So you can use hex, you could use ASCII, and you can also use ASCII combined with hex, as shown here. Yep. So you can also use content modifiers. So
Jordan, can you tell us about the 0D, 0A a little bit?
0D, yes. So that's the carriage return and line feed. So that so the carriage return will so that will put you into a new line, and then the line feed so the line feed will, so together it's like basically like if you were to press like enter on your keyboard. So like in an HTTP request, for example, like each header has so that would basically be like a carriage return line feed would like put you on the next line, and then it would check for like the next HTTP parameter. So I think that's what that is being.
So kind of like a delimiter for the different fields or lines.
Yeah, exactly. Like if you're looking at like an HTTP request, like it would that would put you on like the next line, those 2 bytes. So the 0D, 0A would like put you on the next line. So then the next thing that I want to look at are content modifiers. So a content modifier will modify a string of content. So it will only match on a string of content if it meets a particular condition. So there are several examples. Here's several examples of content modifiers. So the first content modifier is no case. So this would specify that the content would be case insensitive. So by default, Suricata is case sensitive. So by adding a no case content modifier after you specify the content, this would make the it would match case insensitive instead of case sensitive. So it would change the default behavior. And then so depth and offset. So what depth does is it will start at the beginning of the payload, and then depth will specify how many bytes after the beginning of the payload do we want to start checking for a particular match of content. And then the offset will be from which byte we start checking. So depth will like specify the maximum amount for the beginning of the payload, and then offset will specify where you start checking. So the difference, so then distance and within, so depth and offset are absolute. So from the start, so they will check from the start of the payload, whereas distance and within will check from the previous content match. So there's a diagram on the next slides that will represent this a little clearer, but distance will start is the amount, which byte that you will start checking from the previous match. And then so from the previous content match, and then within would be how many bytes will be checked after that. So the maximum byte that you will check after that. So let me show you on the next slide what I'm talking about here. So as we can see, offset will specify where we're starting from. And this is from the beginning of the payload. So offset will specify where we're starting from, and then depth will specify how far we will check, like where the maximum, so like how far we will check after that offset. So for example, offset will start at 3, so we'll start checking right at offset 3, and then depth is set to 3, so it will check from 3 bytes after the offset. So we'll only check from 3 bytes after the offset. So since DEF is between offset and depth, then it will match. So the content is set to depth, so then it will match here. And then so the distance and within, instead of matching from the beginning of the payload, it will match from the last content match. So as you can see, here is the first content match, which is ABC. And then the second content match, DEF. So the distance and within will match from the start of AB. So it's relative to the first content match, which is ABC. So the distance, it will start. So the distance is specified to 0. So it will start. That means it will start right after the last content match, and then within specifies from how many bytes we're checking after that. So it will check the first 3 bytes after distance. But since DEF is not within those 3 bytes here, DEF will not match. So then here are some HTTP specific content modifiers. So the main thing we'll look at is HTTP traffic tonight. So here are just some different HTTP content modifiers. So HTTP method will only match on a specific HTTP method. So here is the content. So this is matching on if we're sending a post, or if a post request is being sent, then this rule will match. And then HTTP host is matching on a specific host name. So if the host name matches this, the rule will match. And then the third is a HTTP stat code. So this will only match on a specific HTTP status code. So if so the content is 200, and then so if the response is 200, then the rule will match. So then another thing I want to talk about is flow bits. So flow bits can be used to chain two rules together. So for example, if you want to match if a specific HTTP request is made and then an HTTP response is made, but you only want to match if both of these are made. So if both the HTTP request and the HTTP response is matched, then you want a rule to be generated based on that. Then you can use flow bits to chain the rules together. So to do this, in the first rule, you would write so flow bit set, and then you would create a name for the rule. So the name, it can be any name, but the name has to match in both of the rule sets. So here I also did flow bits no alert. So that will so basically what that means is that it will only generate a rule. It will only generate an alert if the request and response is made, but it will only then generate an alert based on the response. So that just prevents 2 alerts from being generated from the HTTP traffic. So only 1 alert will be generated. And then so in the second rule, for example, if it's like an HTTP response, you can specify you do is set and then the name of the rule, and then this would match the 2 of them together as 1 rule. So then those are some of the content modifiers, and then so these are basically just some metadata options that are so metadata is like descriptive of the rule itself. So first we have the reference. So the reference is used if you want to add more information about the alert. So for example, if the alert is being generated on a particular malware strain, maybe you'll want to include like a blog post related to that malware. So if that rule is generated, then that person who can like go and find out more information about that malware. So then class type is you can classify what type of threat the alert is being generated on. And then a signature ID is like a unique number. And this one is required, I believe. So this is a unique number for the signature. And then rev is like the revision number. So ideally it would start at 1, and then each time you revise the rule, then it would increment by 1. So here are just some examples of some different Suricata rules that I wrote. So this is the action. So it's alerting. It's alerting if this rule is generated. And then, so we're using the HTTP protocol. The network activity is, so it's inbound from the external network to the home network. And so this is a message of what the malware is. So it's the Angular exploit kit, and then it's detecting the landing page. So as you can see, this message is very like clear and explains well like what it is, and that's important, because when you're reading rules, you'll want to know exactly why the alert was generated. And then here you can see this is the we're using a content match, so it's looking for the ASCII string 200 within the packet, and then it's using the HTTP stat code content modifier. So it's only matching 200 if that is the status code returned. So if that's the HTTP status code, then this will match. So also something else to explain is that if you're looking at a Suricata rule that has multiple content matches, it has to match every single one in order to alert. So it will have to match every content type here in order for the Suricata rule to match. So then the next thing it looks for, so these are sequential. So it will first look for 200 it will look for 200 in the payload, and then, or in the packet. And then after that, it will look for this string here. So application X shockwave flash. So it's looking for like a flash content, and then content length. So it's looking for the content length header. And then it's specifying on an exact content length. And then after that, it looks for the set cookie header. And now we're using some content modifiers here. So what this will do is it will look distance 25. So it will look 25 bytes after the content length header, and then it will within 50. So it will match within 25 bytes after that. So it will match within the next, this content match has to be within the next 50 bytes of that. And then here we're just matching on some hex byte, like hex content. So this is the actual flash executable, and then this is just matching on specific patterns in that executable. And then next we have flow. So this was discussed before. So flow is only matching if the network traffic is headed to the client. And as we can see, it's heading from the external network back to the home network. So we can see that it's headed to the client, and only if that session is established. And then here is the ID of the rule, and then the revision number, and then we classify it as malware. So for the second rule, again, it's alerting. Yes, Bramwell.
So for the SID, the rev, and the class type, you just make up whatever you want, right?
Well, so the SID has to be unique. So if you have like a list of rules, the SID has to be a unique it has to be a unique number, because if you have any rules in like Suricata, if you have two rules with the same SID, that will generate an error. So that has to be unique. And then the revision number, I mean, yes, technically you can, I believe, set it to anything you want, but it's good practice to start that at 1. And then each time you revise it, then you increment it by 1. And then the class type, I think that, not entirely sure about that one, but I think that has to, there's like a list of different class types and it has to like match one of them, but I'm not entirely sure about that.
So basically the SID, you can pick whatever you want as long as it's not in use. There's some people that think they have to go look up a particular SID for something. It's something you can create.
All right, and then so for the second example, so this is based the same here. So it's generating an alert and then on HTTP traffic, but this time it's headed to the external net. So it's destined from our home network and headed to the external network. So it's outbound traffic. And then the message, so it's like a retrieval of a suspicious executable. The content method is get, also looking for a JPEG image that is being requested. So it's within 100. So within 100 bytes of this content match here. So within 100 bytes of the word get, it's looking for the extension, the JPEG extension. And then content is looking for HTTP within 10 bytes of that last match within JPEG. And then this just looking for the content header, accept encoding. This 3A here is a colon, so it's using hex to specify the colon. And then gzip and deflate is the encoding that it's accepting. Then flow to server. So that's kind of I guess a little bit redundant because we're already specifying here that it's headed towards the server, but we do get the added benefit that it's only matching the rule if the traffic is established. So then here is the SID and then revision number, a class type. And so now here we're using flow bits. So as discussed before, flow bits can match a chain of two rules. So flow bit here is set and then to Drydic, so that we can really specify any name here, but they have to match in both rules. So and then flow bits no alert. So if this matches, it's not alerting us on this one, but on the first rule, but it will have to match both rules here for it to generate an alert. So this is the HTTP request. And then here, the second rule is the HTTP response. So so this is, so it's inbound. So from the server to back to the client. And this is the actual executable download. Again, it's retrieving the status code. If the status code matches 200, then it will only match if the status code matches 200. And then it's looking for a content type of an image / JPEG. It's looking for the MZ header. So the MZ header is the magic number used by the PE file format. So that will include DLLs as well as executables. And so it will have 45A and hex, or which is MZ and ASCII. So the first 2 bytes will be MZ. So that will specify that this is an executable file or a PE file. Rather.
Hey, Owen, just to interrupt, I see the next one says this program cannot be run in DOS mode. Does anybody in the club know which part of the PE file that comes from? Do you know, Odin?
Is it like the DOS stub? Is that what it's called?
Yep, correct.
All right, so that is, yep, so the MZ matching on the MZ header, and then, so again, it's using distance and within, so looking 76 bytes after that. So it won't look for anything before, it won't look for anything before those 76 bytes. So then 76 bytes after, and then within 39 bytes after the 76 bytes. So that's probably like the offsets that are specific to a PE file. That's what it's checking for. And then flow is to the client, established. Class type is malware, and then the SID and revision number. And then this is set to Drydic, so it will alert if both of these are matched. So that's just a more specific, a better way you can write rules. So it will only match if an HTTP request and response are both matched there. So the next thing that I want to do is actually do a live demo. So what I want to do here is just look at some network traffic, and then this just to show you like how network traffic can be so just to show you the process of writing a Suricata rule. So first you need to look at the network traffic of the malware, and then you want to identify some unique things about that packet. And then from there you can write a Suricata rule. So I'm going to go to my VApp now, and you don't have to do this in the VApp because it's just a PCAP, so you're not actually running malicious activity on. You're not actually running a malicious program onto your desktop, but it might be helpful. Like if you don't have Wireshark on your local machine, we do have a copy of Wireshark on the VApp for you. So
It should be in the Flare VM and also the Remnix 7 too.
Yep, you can use either one that you prefer. So hopefully you have the VApp powered on by now, but if not, you can should be your name and then Malware Club, and then you just go to actions. Should be able to start it. It's not showing on my screen. Hold on. Oh yeah, power, and then go to start. But mine's already powered on. You're going to want to make sure though that you go to VApps. So all three of the VMs turn on. So let's go to Flare
You need to
VM.
authenticate captive.apple.com.
So you right click actions, then VM console, and if you have the remote console, you can use that. That's what I'm going to be using. But if you don't have that, then you can just launch the web console, which will be okay for now. So to get the malware sample, it's going to be at. So also, if you need the password, it's so the password to access the.
We can't see your remote console if you're trying to show us that.
Oh, right. Okay. Sorry. Let's go here.
And you also, when you get to the Google Drive, which he'll show you in a little bit, you also have to be logged into Google in order for it to let you to download. Otherwise, it won't let you download.
Oh, really? I didn't. So aware of that. It should. I think it should let you download if you're not on Google, but it might not. But yeah, if it's giving you trouble, then just try to sign in, see if that works. So to access the virtual machine, this is the password that you're going to want. Password 1!! Capital P, and then you want to go to drive.malwr.club, and then the Suricata drive. There'll be a folder with today's date and Suricata, and so there's two PCAPs. The first one we're going to look at is this one, Hand Sitor, that one right here with 929. And then I already have that open, but I'll give everyone just a minute to get that all ready.
If you need help, raise your hand.
Yep, I can help you, or Bradwell and Evan can also help.
If everybody's ready, raise your hand. People still working on it. We're doing the hands of tour one. Anybody need more time? Raise your hand. I think we're probably good to keep going, Odin.
Okay, yeah, sounds good. All right, so this is the PCAP. So this is a, so network traffic analysis is where I got this from. So this is a PCAP that was captured of malicious traffic. So we're going to look, so in order to write a Suricata rule, you're going to want a PCAP, and then from that PCAP, then you can look at some unique indicators of compromise of that traffic. And then from there, you can write a Suricata rule to alert on this particular malware sample. So I'm going to show you how to do that. So we're going to want to look for this lesson. I'm going to just keep it as doing HTTP traffic, because that's good, simple way to get started. So I'm going to apply a filter here at near the top left, so where it says apply a display filter, and I'm going to just enter HTTP, and this will filter the packets only that match the HTTP protocol. So here are several different examples of packets that we could write a Suricata rule based on. I'm just going to pick this one here. So it's a post request. So that means that it's actually, so it's sending data to it. So that should be.
Hey, Odin, can I interrupt you for a second? Just to be clear,
Yeah,
so everyone
sure.
understands what this is. It's like a PCAP that's generated when a specific instance of malware was running, and they've deliberately excluded things that are mostly irrelevant, or tried to at least.
Yeah, that's correct. Thank you, Bramwell. So so here, this is so let's just look at this packet right here. Look at some what's going on in this packet. So here we see, so like for example, here we could see that so it's sending a post request. So this is from from the client machine to the server. Then it's sending a post request to the command and control server, but it's here it's the page that it's sending it to is forum.php, and then it's sending multiple parameters to the server. So let's take a look at those. So it looks like it's sending like a form to the server. So here are just the different parameters that it's sending over. So here is the GUID parameter. So here it's sending over. So it's basically, it looks like it's collecting information on the victim computer and then sending it back to the command and control server. So this is the IP address of the client machine. And then this is the desktop. And then this is the domain that they belong to. And then this is their user on that domain. So looks like there's some indicators that we could generate a Suricata rule based on. So for example, we could generate a Suricata rule based on the web page that's being requested. And we can also generate a Suricata rule based on the different parameters that are being sent over. We're going to want to avoid, though, putting in the Suricata rule for the content, like things like the desktop that the local machine belongs to, because then it will only match on this particular request, but for example, for other requests, this value is going to change because this depends on the desktop that the client is using. And then also we're not going to want to include information about the domain because we want this to be broad enough that it can detect other instances of this command and control traffic. Otherwise, if we included information like the domain and the desktop, it would only match when when the traffic is being sent from this particular host. So based on that, I did write a Suricata rule. So rather than trying to write it live, and we don't necessarily have a lot of time to do that, but so I pre-wrote a Suricata rule. So I'm going to go back to the presentation and show that to you.
Hey, Odin, just so you know that the time that in that machine was like 8 minutes fast.
Oh, in the VM? Yeah, I'm not exactly sure why that is. Okay, so we're gonna go back here. Actually, all right, so this here is a basic Suricata rule that I wrote for the malware traffic, for that packet that we just looked at. It's not too advanced, but I just wanted to make it basic enough that it's easy for a beginner to understand. So I'm not going to go over every single aspect because we already went over like what this does. So at a high level though, so it will alert on the HTTP protocol. And so we're having it sent from the home network to the external network on port 80. So this means it's outbound traffic. We are using the arrow pointed to the left. So this means it's the source is the home network, the destination is the external network. And then it's a message of what the alert is, of what this packet corresponds to. So it's related to C2 traffic for Cobalt Strike. Cobalt Strike is a common, I don't know if you call it a Trojan, but I would say Trojan. That it can be used on that is used. And then a content is so it's a post, and then it's matching if the request, if it's a post request, so only matches if it's a post request. We do look for forum.php in the request, but we do specify a distance and with it. So distance, so this is matching after the post request. So this will be so it would be 0. So it starts checking 0 bytes from the end of this string here. So at the end of post, it starts checking, and then within 15, so it only checks 15 bytes after that. But since forum.php is like only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bytes after post, it will match on that. So then we do look for a few different parameters that are being used. So we look for the GUID parameter as well as the IP parameter. And then we look to make sure that the connection is established and that it's headed to the server. So this is broad enough that it should be able to detect similar types of C2 traffic. So now I want to give you a chance if you want to write your own Suricata rule. As mentioned before, like this PowerPoint is available on the Suricata drive. So if you want to reference anything that I talked about, like any of the different options or methods that are used in writing Suricata rules, you can. And then so I created another, there's another PCAP for you in the drive. It's 20, so it's 2021-10-20, and then So then you can run that and then just inspect the network traffic and look for some unique indicators of compromise with that traffic. And then from that, you'll be able to write a unique Suricata rule for that traffic. So that's that's a little exercise that you could do if you're interested. And then I'm going to.
Do you open it up for us?
Yeah, absolutely. So let's go to. So I'm going to share my screen here and then. Right. And I'll just get you started a little bit on the activity. So, so this is
Or maybe you could ask the audience and see if anybody there has like any ideas on maybe like a first step once you get it open.
Yeah, we could do that. Yeah, that sounds good. Just make it a little more guided. I like that. So just loading all the traffic.
So right now in this the room right now, Evan has a microphone and he's gonna, once loading gets that loaded, we can maybe try to figure that out. And if you have a thought you want to contribute, then just raise your hand and he can come to you with the microphone, or you could just say it.
All right. So if we want to look for HTTP traffic, what would be the first step that we would need to do to filter based on, like, so we can view only HTTP traffic?
And do we have a hand up over there?
So we're gonna have to type HTTP in the filter or the search filter box, I think it is.
Yes, that's correct. So we go to the display filter and then enter HTTP. And as you see here, there's not a ton of traffic, but that just makes it simpler for us, so we don't have a lot of options of different packets that we can use to write a Suricata rule based on. So let's take a look at this one here. So this is let's take a look here.
And does anybody see anything that pops out to them either on the screen or their laptops?
All right.
You want to ask them a guiding question, Odin?
Yeah. So here, I guess, so let's look at this. Well, actually, let's look here right at this sample right here. So I'm just trying to find a good example. Yeah, maybe this one. So what's some good, what would be some unique things about this packet that we could use to write a Suricata rule based on? So here's some information about the packet. So here, let me make this maybe bigger so you can see more information about the packet. And then, so yeah, maybe take like a minute to look through this packet and then tell me like what are some unique things about this packet that you might be able to write a Suricata rule based on.
Is anybody seeing like web addresses anywhere in either this packet or another packet?
I did get one response in the chat. So Soul says domain name, and yes, that is something that you could write a Suricata rule based on that would be unique. So you could so like here it's okay, and then so like the host name, yeah, you could, or maybe you could write like, so it's download. So we could see here that it's downloading a file from this domain here. So maybe you could like match on the content of the domain name. And then there are also rules in Suricata that allow you to, like, for example, when a certain domain is requested, it will allow you to match based on the host name. So we could set a Suricata rule to like a match on the host and then have this host name here. And then I think there is a content modifier in Suricata that works for host name. And that's good if you're looking for traffic that is unique. Like if you're only interested in looking for traffic that originates from this particular host, then that would be a good indicator of compromise to use. But if you're looking for, like, if you want to see if for example, if there are multiple host names that are like multiple websites that are hosting this payload and you want to detect traffic from multiple different websites, then maybe the host name wouldn't be what you'd want to use. Maybe you'd want to use like more specific things in the actual packet itself. So let's take a look here. And
I don't know if this is correct or not, but I just saw that reg server 32.exe calling the path in that previous one, or I think, and that looks pretty sus if it's in like the HTML data.
let's take a look there. Yes, that would be a very good indicator of compromise that to use, since this looks like it's so yeah, it's getting like the Windows registry somehow. So download, yeah, so that may be like matching on Windows System 32 and then Reg Server 32. That could be a good content match to use. You could also match on like you can match on the page, like you can match on main.php, or you can match on this this folder name here, although that could change in different payloads. So that might, yeah, so downloading file, that would be a good one to match on. So let's take a look at that. So yeah, so maybe you could do a content match on like download file. So this is pretty
What about
suspicious.
do you see the dot date? Or dot dat? The left
Dot-
under path. Environment temp and then plus.
Oh, yes. Oh, yeah. Yeah, that would be a great one. Yeah. So you could match on the on this particular file name, or the match on this string here, environment temp.
Is there an HTTP status code that comes along with the downloads?
So no, so it's just so the 200, well, the 200 response will is returned after so the 200 response would be indicate that the in this case that
That's successful.
it was successful. Yeah. Mhm. You might be able to match on some of this information. So the chunked response. So this looks like it's in some type of octet form. So let's look at here. So looks like some type of encoded data. Maybe you could use like a content batch on some of these hex bytes, and then from that could well, this is actually a part of the client file. That actually looks like it's part of the file being downloaded. But, But yeah, I think those are some very good ideas of like what of some different unique things about this HTTP response that you could write a Suricata rule based on. So I think that's all I have for that. I did write like an example rule, but I think it was actually for the wrong PCAP, so it's not actually for this one. But were you gonna
Yeah,
say
Alden,
something?
as a club, we do get club funding, so we do have like $500 basically. How about we do like a $10 gift card, and maybe people want to do this activity, and you could send it to Odin, and maybe Odin and Evan could like judge the best one, and then whenever we meet next, then we can give that to whoever creates the best Suricata rule. Or
Yeah, I like that
actually,
idea.
no, that doesn't work because we haven't yet taught them how to use Suricata, so.
Oh, I
You
see.
can have
Yeah,
an idea how to write it, but if you're not actually testing it, then it doesn't do any good because it doesn't work and it's just a waste of time.
yeah. I
So
mean,
maybe
you
we'll
could
save that for next time, maybe some kind of a gift card or some kind of prize that we can give. And on a similar note, one thing that the leadership, Odin and Evan have been discussing is a possible thing is maybe some kind of CTF thing or some kind of competition in the future, and maybe try to find some kind of bigger prize to give, or maybe jackets or something. So that could possibly be on the horizon. Do you have anything else you want to say, Evan?
Nothing important. I would implore you guys though, if you're interested in like the movements of ransomware groups and stuff, go read Conti's most recent announcement because it's hilarious. But other than that, nope, I'm good.
All right,
So-
yeah. Well, thank you, everybody, and thank you for like participating in the exercise. And then so next, so next malware meeting, we will be probably continuing our using Suricata. So I'll actually be showing you like how to configure and run Suricata. And then that will probably take up half of the meeting. And then for the other half of the meeting, we'll probably be looking at a malware sample. I haven't decided which one yet, but we'll be doing like some dynamic analysis on a malware sample, most likely. Or we might have a student speaker present. We're not sure yet, but I'll keep you updated.
Yeah, we're always looking for student speakers, whether you're online or in person. I remember when I had Odin in my malware class, he was one of the shyest students, but now he's doing all these presentations. So don't be shy. If you have things that you feel capable of speaking on, just give it a try.
Yep, that sounds good. All right. Thank you, everybody, and I'll see you at the next meeting.